Hi, welcome to this Corbettmaths video. In this video, we're going to look at the GCSE Further Maths topic of quadratic graphs, and we're going to look at sketching quadratic graphs. So, sketching quadratic graphs is a very important skill for GCSE Further Maths because they often appear in what I call the big graph questions, where you're actually asked to sketch a quadratic graph. But you might even need to be able to sketch quadratic graphs for perhaps the area under a graph using integration and things like that. So, to sketch a quadratic graph, there's some steps that I take whenever I'm sketching a quadratic graph. The first step is I consider the shape of the graph. Obviously, a quadratic graph will be in the form y equals ax squared plus bx plus c. So you're going to have something in that form where you've got an x squared term, and you may or may not have an x term and a constant on the end, but there'll definitely be an x squared term. And to consider the shape, what we do is we look at the coefficient, the number in front of the x squared. If it's positive, so if it's perhaps x squared or 2x squared or 3x squared, you're going to find that the shape of the graph is a U-shaped parabola. So you end up with that U-shaped graph. If the coefficient of x squared, if that value of a is negative, so perhaps minus x squared or minus 2x squared or minus 3x squared, you're going to find that the parabola is an N shape. It'll be an N shape like so. So if the coefficient of the x squared is a positive, if it's a positive coefficient, you'll find it's this U-shaped graph. And if the coefficient of the x squared is negative, then you'll find it's an N-shaped graph. And it's important to know whenever you look at the quadratic that you're trying to sketch, you can actually look at that x squared term straight away and see if it's going to be a U-shape or an N shape by just looking to see if it's positive or negative. So that's quite important. And then what we would do is our step 2 would be to find out where it crosses the x-axis. So where a graph crosses the x-axis, the height is equal to 0. So if we let y equal 0, so here if we had this quadratic, you'd do 0 equals a quadratic, and then you'd solve it. And then those solutions will be where the graph crosses the x-axis. Now you may find that there's two different solutions, two unique solutions. So the graph crosses the x-axis twice, so the U-shaped parabola will go through the x-axis twice. It might be there's only one solution, one repeated solution, so that means that the quadratic touches the x-axis. Or you might actually find there's no solutions. You might actually find you can't actually solve that quadratic whenever you let the y equal 0, and then that means that the graph doesn't actually cross the x-axis. Okay, so that's our first two steps. My next step would be to find where it crosses the y-axis, and all quadratics will cross the y-axis. And to find where it crosses the y-axis, we just let x equal 0. So we just let x equal 0, and that'll be where the graph crosses the y-axis. So you can find that y-intercept. Okay, so they're the first three steps I would use if I was sketching a quadratic. And then finally, depending on the question, I may also want to label the coordinates of the turning point. And that video shows you how to find the coordinates of turning points, those stationary points, minimum points or maximum points, by using differentiation. And also video 646, where in video 646 I go through all the steps of those big graph questions, and that will include finding the coordinates of turning points. Okay, so they're the steps that I would use if I was sketching a quadratic graph. I would consider the shape, I'd find where and if it crosses the x-axis, where it crosses the y-axis, and I'd also label the coordinates of the turning point if I'm asked to. Okay, so let's have a look at our first question. So our first question, we've been asked to sketch y equals x squared plus 5x plus 6. So we want to sketch that quadratic graph. So let's go through the steps. Step 1. Step 1 would be to consider the shape of this graph. Well, if we have a look at it, it's x squared. That means the coefficient here is 1. It's 1x squared. Now, we don't write the 1 there, but it is 1x squared, and that's positive. So it's an x squared graph, and an x squared graph will be a U-shaped parabola. So this graph will be a U-shaped parabola. Okay, so that's the shape of the graph. So we've done our first step, which was to consider the shape of the graph. So it's x squared, that's positive coefficients, that's a U-shaped parabola. Okay, step 2, let's find where it crosses, or if it crosses the x-axis. And to find where it crosses the x-axis, we're going to let y equal 0, because where it crosses the x-axis, the height of the graph is 0. So if we let y equal 0, we're going to get 0 equals x squared plus 5x plus 6. And then let's try and solve this quadratic, and if we can solve it, it'll tell us where this graph crosses the x-axis. So to solve this quadratic, I'm going to try factorization to begin with. So let's do 0 equals, and then bracket, 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 bracket. And let's put x's at the front of the brackets. So an x here and an x there. Okay, so that's great. Now let's find the numbers that would go inside the brackets. So because it's just an x squared, we can just consider two numbers that will times together to be 6 and will add together to be 5. So I'm thinking 3 and 2. So plus 3 and plus 2. Because 3 times 2 is 6, and 3 plus 2 is equal to 5. Now we want to find when it's equal to 0. So when it's equal to 0 will be when either one of these brackets is equal to 0. So to make this bracket 0, x would be equal to negative 3, or here x would be equal to negative 2. So there are two solutions, x equals negative 2 and x equals negative 3. So they're going to be where the graph crosses the x-axis. It's going to cross the x-axis at negative 2 and negative 3. So negative 3 here and negative 2 here. So that's our sketch of our quadratic. And I'm just going to label some of the points. It crosses here at negative 3 and negative 2. Or you could write it as coordinates, so you could label it like that. If you're asked to label the coordinates of the points, I would probably actually write them like this: negative 3, 0, and negative 2, 0, like so, just label them as full coordinates. But if you're just doing a quick sketch, you could just write negative 3 there and negative 2 there. Okay, so we've done a sketch of our quadratic, that U-shaped parabola. We've labelled where it crosses the x-axis. Now let's find where it crosses the y-axis. And to find where it crosses the y-axis, we let x equal 0. So let's let x equal 0. So if we let x equal 0, we're going to get that y equals 0 squared, so 0 squared, plus 5 times 0, well that's 0, plus 6. And if we work this out, 0 squared is 0, plus 0 is 0, plus 6 is 6, so y equals 6. So that means it crosses the y-axis at 6. So it crosses here at 6. And again, if you're just doing a quick sketch, you could just label it as negative 3 there, negative 2 there, and 6 there. If you're writing down the coordinates of the points, or want to label clearly the coordinates of the point, I would label it as 0, 6. So 0 along, 6 up. And that's it. So if I was asked to sketch this quadratic, I probably would just do a sketch like this, where I would show where it crosses the x-axis, where it crosses the y-axis, and showing the shape of the quadratic. So that's what I would usually do. However, sometimes in these big graph questions, you're asked to also label the coordinates of any turning points as well. So I'm going to do that now as well, because in these GCSE Further Maths questions, you're quite often asked to label those turning points, or those minimum or maximum points. So what I'm going to do is I'm going to show you how you'd find that as well, how you would label it on the graph. So let's do that. Okay, so there's our sketch. Now what I'm going to do is I'm going to find the coordinates of the turning point here, this minimum point. So there's a minimum point here where it's a turning point where the gradient's equal to 0. So to find the coordinates of that turning point, the question might actually get you to do that before you sketch it. So there might be actually a part A where you've got to find the coordinates of the turning point first and then just put it on the diagram whenever you're sketching it. But I'll just have a look and see now how we would find the coordinates of that turning point. So to find the coordinates of the turning point, you know the gradient's equal to 0. So that means that dy by dx, so dy by dx will be equal to 0 for the turning point. So what we're going to do is we're going to differentiate this. So if y is equal to x squared plus 5x plus 6, dy by dx, when you differentiate it, would be equal to. So remember, we bring down the power, so that's going to be 2, and then x, and then you're going to reduce the power by 1. It was squared, you're bringing it down to 1, but you're not going to write 2x to the power of 1, you're just going to write 2x. So we've done the first term. Next, differentiating 5x would just be 5, so plus 5, and then that's it. So if we wanted to differentiate x squared plus 5x plus 6, the answer would be 2x plus 5. So dy by dx is 2x plus 5. That's the gradient function. Now we want to find the coordinates at this point here, and that's when the gradient is equal to 0. So that means that 2x plus 5 is equal to 0. So 2x plus 5 is equal to 0. And now we're just going to solve this equation. So we're going to take away 5 from both sides of the equation to get that 2x equals negative 5. And then we're going to divide both sides of the equation by 2 to get that x equals negative 2.5. And that's it. So that's the x coordinate of the turning point. So here, this point here, if we just label it here in blue, like the other ones, for the turning point here, it's going to be negative 2.5 something. Now, actually, just to mention here that I like to use differentiation whenever I'm finding the coordinates of turning points. And actually, for the big graph questions, they lead you into it, where they ask you to use calculus to find the coordinates of the turning point. So you have to be able to do this anyway. But there are other ways to find the coordinates of those turning points as well. Because remember that the parabola is symmetrical. So if it crosses the x-axis at negative 3 and negative 2, it has to be negative 2.5 in the middle of those because it's symmetrical. So that's a good check. We know if I didn't have negative 2.5 here, I'd be thinking that perhaps I've done something wrong. Also, you could use completing the square as well, but I think that this is a much easier approach. Okay, so we find the x coordinate. X is equal to negative 2.5 for that turning point. Now we're going to substitute that back into the equation to find out what the value for y is, the y coordinate. So y is equal to, and then instead of x squared, we're going to have negative 2.5 squared plus 5 times negative 2.5 and then plus 6. So just replace the x with negative 2.5. And when we work that out, we get an answer of negative a quarter. So negative a quarter or negative 0.25, depending on how you've worked it out there. So that would be negative 2.5, negative 0.25. And that's the y coordinate there. And that's it. We've found the coordinates of that turning point. So that's how I would sketch that quadratic. Okay, let's look at our next question. Okay, so this time we've been asked to sketch y equals negative x squared plus 3x plus 10. It's a negative x squared, it's negative 1x squared. So that coefficient of the x squared, that number for the x squared is negative. So that means it's going to be an n-shaped parabola, this one. So that's an n-shaped parabola. And that's our first step. Okay, so we've considered its shape, we've sketched our axes. Okay, our next step is to find where it crosses the x-axis, if it crosses the x-axis. So we're going to let y equal 0. And whenever we let y equal 0, we're going to get 0 equals negative x squared plus 3x plus 10. And we want to solve this. So to solve this, what I'm actually going to do is I'm going to add x squared minus 3x and minus 10 from both sides, because here we've got a minus x squared. So I'm going to bring everything to the other side. Another way to do is to multiply everything in the equation by -1. So you can times it all by -1. So there's a few different approaches we could use here. But if I add x squared to both sides, it would go to that side. If I take away 3x from both sides, it would go to that side. And if I take away 10 from both sides, it would go to that side. And then the other side would be left with 0. Alternatively, times everything by -1. 0 times -1 is 0. Negative x squared times -1 would be x squared. 3x times -1 would be negative 3x, and 10 times -1 would be negative 10, so you'd end up with this. Okay, so we've now got our quadratic and it's equal to 0. So now let's solve it. So let's factorize. So bracket, 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 bracket equals 0. And then if we factorize this, let's see what we get. So in the front of the brackets, we're going to put our x's because it's x squared. And then we want to find two numbers that will times together to be negative 10 and add together to be negative 3. So I'm thinking negative 5 and plus 2. And if you expand those brackets, you would get this quadratic. Now let's find our solutions, because obviously the two brackets times together to be 0. So that means that either x equals 5 to make that bracket 0, or x equals negative 2. That's fantastic. We now know that our parabola, our quadratic, crosses the graph at 5 and negative 2. And remember, it's an n-shaped parabola. So let's do a little sketch of it here. It's going to cross at negative 2 and 5. Negative 2, 0, like so. And here, 5, 0. Okay, so we've now found where the parabola crosses the x-axis. Now let's find where it crosses the y-axis by letting x equal 0. So let x equal 0. And if we let x equal 0, we get y equals negative 0 squared, that's 0, plus 3 times 0, that's 0, plus 10. So we found that y is equal to 10. So that means it crosses the y-axis here at 10, 0, 10. Okay, so that's fantastic. And that's it. So if we were asked to sketch that graph, and we're just asked to do a sketch of y equals negative x squared plus 3x plus 10, that would be my sketch. If the question asked me to label the coordinates of the turning point as well, let's see how we would do that. So I'm just going to get rid of this working out and find the coordinates of that turning point, that maximum point at the top of the graph. For the turning point, dy by dx will equal 0. And remember that this quite often will be included in those big graph questions before you get to the point where you're sketching it. So you'll have already found the coordinates of that turning point anyway. So it's just a matter of labeling it on the graph anyway. But let's find the coordinates of that turning point. So dy by dx would equal, let's differentiate. So bring the power down, so minus 2x, and reduce the power by 1, so minus 2x. And then we have plus 3x, we're going to differentiate that, so it'll be plus 3. And then that's it. So we've differentiated. Now we've differentiated, what we're going to do is we're going to let it equal 0, because we know that for the turning point, the gradient is equal to 0. And then if we solve this, we'll find the x coordinate of this point. So let's add 2x to both sides to get that 3 is equal to 2x. And let's divide both sides by 2, so we get that 1.5 equals x. So that means that the x coordinate of that turning point there would be 1.5, or 3 over 2. And again, that makes sense because the graph is symmetrical. We've got negative 2 and 5, and the midpoint of negative 2 and 5 would be 1.5, so that's why that would be 1.5 there. Okay, so we've now found that. And also remember that the questions will ask you to use calculus to find the coordinates of that turning point, so you do need to be able to differentiate this and work that out. Okay, now you find out what the x coordinate is. Let's substitute that back in and find the y coordinate. So y is equal to minus 1.5 squared plus 3 times 1.5 plus 10. And this is a calculator paper, so let's just work this out. And when we work that out, we get an answer of 12.25. So that means the y coordinate is equal to 12.25. Or it may come up as a fraction on your calculator, and if it comes up as a fraction, it would come up as 49 over 4, 49 quarters, but I've just got it coming up as a decimal there. And that's it. So that's the coordinates of the turning point, and I've labelled that as well. Okay, let's look at our next question. So next question, we've been asked to sketch y equals 2x squared plus x minus 15. So we want to sketch this quadratic, so let's go through our steps again. So step 1, let's find its shape, or consider its shape. It's 2x squared, so that's a positive coefficient for x squared. 2 is positive, so it's going to be a U-shaped parabola, so it's a U-shape. Okay, step 2, let's find where the graph crosses the x-axis by letting y equal 0. So we're going to let y equal 0, so we're going to have 0 equals 2x squared plus x minus 15. Now let's try and factorize this. So to factorize it, let's put our brackets down and write 2x and x. Now, it may be sometimes you may need to use the quadratic formula or completing the square, but hopefully it'll factorize. Okay, so we've got our 2x and our x. We now are going to have two numbers of times together to be negative 15, and when we put them in the brackets and expand, we get our plus 1x in the middle. So I'm thinking 3 and 5. So I'm thinking if I put the 3 there and the 5 there, we would get 6x. So let's make that positive and that negative. And that's it. We're factorized. Okay, so now let's find our solutions. We want to find when each bracket is equal to 0. So here, x would be equal to negative 3. And here we've got 2x minus 5 equals 0. So it means that 2x equals 5. So it means that x equals 5 over 2 or 2.5. So I'm just going to write 2.5 there. Okay, so that's fantastic. We've now found where the graph crosses the x-axis. It crosses the x-axis at negative 3 and 2.5. So let's sketch it. And so let's label these points. That'll be negative 3, 0, and that would be 2.5, 0. So we've labeled the points where the graph crosses the x-axis. Now let's find where the graph crosses the y-axis, so down here. And we'll get a spot that that's just going to be negative 15 straight away, because whenever x is equal to 0, you substitute x equals 0 in, we're going to get the y equals 0 squared times 2 is 0, plus 0, 0, minus 15 will be minus 15. So the coordinates of this point here will be 0, negative 15. So that's fantastic. We've now got the coordinates of that point, and that point where it crosses the x-axis and the y-axis. Now let's find the coordinates of the turning point, because remember, for these big graph questions, you're quite often asked to label the coordinates of those turning points, so this minimum point here. Okay, so to find the coordinates of the turning point, remember, it'll often be done as its own part of the question, but what we're going to do is we're going to find what dy by dx is by differentiating this. So we've got y equals 2x squared plus x minus 15. And if we differentiate, we'll bring the power down, so that'll be 4, because 2 times 2, and then x, and then reduce the power by 1, so just 4x. And then when we differentiate x, that's going to be differentiating 1x, so we'll just be left with 1. So we've differentiated it. Now we're going to let, and obviously differentiating negative 15 would be 0. So that's it. Now we're going to let that equal 0, because we know for the turning point the gradient's equal to 0. So 4x plus 1 equals 0. And then when we solve this, let's take 1 away from both sides. So we get that 4x equals negative 1. And then if we divide by 4, we get that x is equal to negative a quarter, or you could write it as negative 0.25. Okay, so we've found the x coordinate of the turning point, which is equal to negative 0.25 or negative a quarter. Okay, so we found the x coordinate of the turning point. Now let's substitute that back in to find the y coordinate. So we're going to do, let's just go up here a second, equals 2 times negative 0.25 squared plus negative 0.25 subtract 15. And when we type that into our calculator, let's see what we get. Negative 15.125. So that means that this point here will be the point negative 0.25, negative 15.125. And that's it. So we've sketched that quadratic, and we found where it crossed the x-axis, where it crossed the y-axis. We had its shape, and we also labelled on the coordinates of that turning point. Okay, let's take our next question. So our next question, we've been asked to sketch y equals 4x minus 3, close brackets, x plus 1, close brackets. So this time it's been factorized, and we need to sketch it. So to sketch it, we would consider its shape. If you expanded the bracket, you'd get 4x squared. And 4x squared, the coefficient of x squared is positive, so it's going to be a U-shaped parabola. You could expand the brackets and get, if you expanded the brackets, you'd get 4x times x is 4x squared. 4x times 1 would be plus 4x. Minus 3 times x would be minus 3x. And minus 3 times 1 would be minus 3. And then if we simplify that, we get 4x squared. 4x take away 3x is plus 1x, and then we've got minus 3. And as you can see, it's 4x squared, so the coefficient of the x squared is positive, so it's a U-shape. Okay, so that's part 1. Part 2, let's find where it crosses the x-axis. And to find where it crosses the x-axis, we're going to let y equal 0. And if we let y equal 0, we're going to get 0 equals. And I'm going to use the factorized version here, because that's actually quite handy whenever we're trying to find its solutions, because we can just look at it and say, well, here, x would be equal to negative 1 to make that bracket 0. And to make this bracket 0, 4x minus 3 equals 0. So 4x equals 3. So that means that x equals 3/4. So 3/4. And that's it. Okay, or you could write it as x equals 0.75, whatever you prefer. So that means that this U-shaped parabola, this quadratic, will cross the x-axis at negative 1 and 3/4. It's going to look something like this, where it crosses at negative 1, 0, there, and it also crosses here at 3/4, 0. So we've found where it crosses the x-axis. Now let's find where it crosses the y-axis. And to find where it crosses the y-axis, we're going to let x equal 0. So we'll let x equal 0. And we'll substitute that back in. Now you can substitute them back in here, and if you do that, you're going to get 0 minus 3, and that's equal to negative 3. You get that here 0 plus 1 is equal to 1, and negative 3 times 1 will be equal to negative 3, so y is equal to negative 3. Or you could go back to this one and substitute in 0, and you get that 0 plus 0 minus 3, well, it's going to be equal to negative 3. So it's going to cross the y-axis here at 0, negative 3. Okay, so we've labelled the coordinates of the x-intercepts where it crosses the x-axis, the y-intercept, 0, negative 3, and then finally, if you're asked to label the coordinates of the turning point on the quadratic, so obviously remember for those big graph questions, you're often asked to do that, so let's do that now. Okay, so to find the coordinates of the turning point, we're going to differentiate it and put it equal to 0. I'm using the expanded version here because obviously we would want to expand our brackets before differentiating, so dy by dx would equal, and differentiating this, bringing the power down, so 4 times 2 is 8x, and then reduce the power by 1, so just be x to the power of 1, so 8x, and differentiating x, or plus 1x, would be plus 1, and that's it, we've differentiated. Now the gradient is equal to 0, so that we're going to write 8x plus 1 equals 0, and if we take 1 away from both sides, we get that 8x equals negative 1, and then if we divide both sides by 8, we get that x is equal to negative 1/8. So that's fantastic. We've found the x coordinate of the turning point. So it's going to be there somewhere just to the left because it's negative 1/8. So it's just to the left of the y-intercept. So we've got that the x coordinate of the turning point is negative 1/8. And now let's find the y coordinate of the turning point. And you can substitute this back into either here or here. So either one. And if you do that, you're going to get that y would be equal to negative 49/16. I'm not going to write that as a decimal, I'm just going to leave it as a fraction of this question, just say that's fine as well. So negative 49/16. And that's it. And that's it, we've sketched that quadratic. Okay, let's have a look at one last question. So this time we've been asked to sketch y equals x squared minus 2x plus 4. And I've chosen this one on purpose because earlier on in the video, whenever we talked about finding where it crossed the x-axis, we said let y equal 0. And I said that it may cross the x-axis at 2 different locations. It may just touch it at one location, or it may not cross the x-axis. And this is an example of a graph that doesn't cross the x-axis. And remember, for those big graph questions, before you're asked to sketch it, you're quite often asked to perhaps find the coordinates of the turning point. And then if you find the coordinates of the turning point of this graph first, it'll actually then help you understand that it won't actually cross the x-axis. So let's have a look at this question. So we want to sketch this. So the first thing I would do is I would consider its shape. And it's x squared, or 1x squared, so the coefficient of the x squared is positive, so it's going to be a u-shaped parabola. So it's going to be a u-shaped graph. Okay, next I would consider where it crosses the x-axis. Now, if I was doing this on the big graph questions, quite often I would ask you to use calculus to find the coordinates of the turning point. So I'm going to come back to that later, because if you were to let y equal 0, you would end up with 0 equals x squared minus 2x plus 4. You wouldn't be able to factorize it, and actually you wouldn't actually be able to solve it. There's no solutions, so you wouldn't be able to solve it. So the next step is I'm going to then find where it crosses the y-axis, and it crosses the y-axis at 4, because remember to let x equal 0, we get that y equals 0 squared minus 2 times 0, that's 0, plus 4. And that means that y equals 4. So it crosses the y-axis at 4. So at the minute, we know its shape, it's a U-shaped parabola. It could be over this side like that. It could be over that side like that. It could even be in the middle like that. We're not entirely sure where the graph is. But we do know it crosses the y-axis here at the point 0, 4. Okay, so we've considered its shape. We haven't found where it crosses the x-axis because it doesn't, and we've also found where it crosses the y-axis because we know it crosses the y-axis at 0, 4, because we let x equal 0. Okay, and then because this question would often be part of a big graphs question, part of that question would be previously we'd have found the coordinates of the turning point. So let's find the coordinates of the turning point of this graph. So let's find dy by dx. So we've got the y equals x squared minus 2x plus 4. So dy by dx, if we differentiate it, we're going to bring the power down to x, reduce the power by 1, so that's it. And then differentiating minus 2x will be minus 2, and then that's it. So dy by dx is equal to 2x minus 2. Now we're going to let that equal 0 because we know that for the turning point the gradient's equal to 0. So we get the 0 equals 2x minus 2. If we add 2 to both sides, we get the 2 equals 2x. And if we divide by 2, we get the x equals 1. So that means that the x coordinate of the turning point will be 1. So it's going to be over here somewhere. So actually now we know the shape of the graph. It's going to look like that. Okay, but let's substitute that back into the equation. So y equals 1 squared minus 2 times 1 plus 4. And so y equals 1 squared, that's 1, minus 2 plus 4. And 1 minus 2 is equal to minus 1, plus 4 is equal to 3. So that's equal to 3. So that means that the coordinates of the turning point would be 1, 3. Now that's above the x-axis. So we've got our x-axis and y-axis. 1 across 3 up is the lowest point of the graph. That's the lowest point of the quadratic graph there. So that's the turning point. So that means the quadratic graph must look something like this, where it comes down to the turning point and then back up again. And then we would label it here as 0, 4, and this point here would be 1, 3. And that's it. And it doesn't cross the x-axis. And if you've done that as part of the question already, whenever you come to sketch it, you can go, well, I found it crosses the y-axis at the point 0, 4. I know the minimum point already is 1, 3. So now I can just do a quick sketch. And that's it. And that's it. So that's how, for GCSE Further Maths, I would sketch quadratic graphs. So I'd consider the shape first of all, considering the coefficient of the x squared. If the coefficient's positive, then it would be a U-shaped parabola. If the coefficient's negative, it would be an N-shaped parabola. I would consider where it crosses the x-axis. If it crosses the x-axis, I'll let y equal 0 and try to solve it. And if I can solve it, then I'll find the solutions. If there's 2 solutions, it'll cross the x-axis twice. If there's the same solutions twice, a repeated solution, it'll just touch the x-axis. And if there's no solutions, quite often earlier on in the question, you'll have used calculus or differentiation and found the coordinates at the turning point. You'll figure out there are no points where it crosses the x-axis. And also we found out where the graphs cross the y-axis by letting x equal 0. And finally, quite often for these big graph questions, you'll have worked out the coordinates at the turning point already. And then if you know that, then that'll help with your sketch, and it means you can sketch quite quickly and easily. And that's it. So I really hope you found this video useful. If you found this video useful, or you found any other of the Corbettmaths videos, the GCSE Further Maths videos useful, please recommend them to a friend or to your teacher and so on. And thanks very much. Oh, and also please like the video and please subscribe. Thank you. Cheers. Bye.